did we say there are to show electron configuration? 3. So there are 3 ways to show it, and we have learned one of them. And that first one is called what? A few of you, as you came in, said, I don't remember what it's called, but I know how to do it. You're showing each individual what? Each individual orbital. This is called orbital notation. Why does it matter that you know what they're called? Because on your test for this chapter, I'm going to ask you to show me this type of notation, this type of notation. And if you put down the wrong type of notation, I'm going to mark it wrong. So you do need to know which is called what. This first one is orbital notation. In orbital notation, you actually show the individual orbitals. Okay, that seems simple enough. Orbital notation shows the orbitals. Now, what we're showing for these atoms is what's called their electron configuration, or sometimes abbreviated as E-config. The second one, and this is where it gets weird, the second format is called electron configuration notation. So all of these show electron configuration, but the second one is actually called electron configuration notation. Sometimes, again, shortened as E-config notation. They're all showing electron configuration, but the second one is actually referred to as electron configuration notation. And it's a shortcut. You don't have to show the individual orbitals. In electron configuration notation, what we show instead are the subshells with a superscript that tells you how many electrons are in that subshell. Okay? It is not an exponent. That's important. So let's do an example where we show the orbital notation, and then we're going to show the E-config notation so that you can see how they're related. I guess we could talk about it in these terms. So when you do electron configuration notation, like I said, E-configuration notation, you write the sublevel designation, and a number of electrons in that sublevel is added as a superscript. Again, it is not an exponent. It is a superscript. Super just means above. You have subscripts and superscripts. 1s2, 2s2, 2p3 is an atom that has 7 electrons. 1s2, 2s2, 2p6 is something with 10 electrons. Just like with orbital notation, you have to make the little triangular chart with the arrows, because if you don't, you're going to screw up your crossovers. So you always have to use that. Let's practice one together. A word about that. I stuck that in there. I didn't draw it. But get used to drawing it, because you're going to have to draw it on your quizzes. You're going to have to draw it on your tests. So don't just do the cheat of using the one that's already been done for you. You need to know how to draw that. Fluorine's always fun. You got your periodic table out? You should. Get your periodic table out now. Fluorine's got 9 electrons. We're going to start off by doing the orbital notation. So I'm going to do the orbital notation in white chalk, metaphorical chalk, digital chalk. Whew. So with 9 electrons, I know I'm going to show 1s, 2s, 2px, 2py, 2pz. And I know that I've got 1, 2, 1, 2, 1, 2, 3. I'm up to 7, 8, 9. Would you agree? Okay. What I'm going to do to show the electron configuration notation is I'm just going to take each individual subshell. The 1s subshell has how many electrons in it? 2. Boop. That's what I'm showing. The 2s subshell has how many electrons? 2. That's what I'm showing. All of those 2p orbitals together make up the 2p subshell. 2p subshell has how many electrons in it?
2.
Look. 5. because this whole thing is the subshell. So we would show that as 1s2, 2s2, 2p5. Okay? Let's do a couple bigger things. I wasn't recording for any of that. Ha, 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 ha. So in each of these, we're just looking at how many electrons are in that subshell. Starting off doing this, you probably will still, for a little while, need to do the orbital, but you'll get faster at it. And you will not ever have to draw orbitals again once you get past this test. Electron configuration notation is usually the shorthand that chemists use when they talk about electron configuration. They'll say something has, and they'll just reference the last subshell. Well, it's got a 3p3, which tells you how it bonds and how it interacts with other elements. So that's, this really you're starting to get to the part that's actually used, that's actually functional. Okay, what I'm going to do is assign a few more practice problems. I'm going to give you a little bit of time to work. So number 24 and 25 are added to the homework. That gives you some more practice at writing the electron configuration notation. And tomorrow there's a FIP quiz on the first two styles of notation. Okay, that's it.